Hello guys, welcome back to the AIME problem solution video. Today we have yet another question here, and as always, let's first start off by reading the question. So, a real number a is chosen randomly and uniformly from the interval -20 to 18 inclusive. The probability that the roots of the polynomial x to the power 4 plus 2a x to the power 3 plus 2a minus 2x squared plus minus -4a plus 3x minus 2 are all real can be written in the form of m over n, where m and n are relatively prime positive integers. Let's find m plus n. And so let's first start off by using the rational root theorem. Now this theorem says that the possible rational roots for this equation here could be x equals 1, -1, 2, and -2, as these are all factors of -2, which is the final coefficient. Now this means that these are the possible roots of this polynomial here, but that might not be true for all of them. So now we're going to have to plug in these numbers all the way into here. So let's first look at f1. If you plug in 1 into f here, which is going to be a polynomial, so I'll just write this here. Fx is going to equal to this. We see that this is going to be equal to 1 plus 2a plus 2a minus 2 minus 4a plus 3 minus 2. And this is going to be equal to 0. So this means that x plus 1, this means that x equals 1 is correct, and we can use it. Now let's look at something else. Let's look at f minus 1. So we're going to plug in minus 1 into here. Here we get 1 minus 2a plus 2a minus 2 plus 4a minus 3. And this is not, a minus 2 at the end, and this is not going to be equal to 0. Now let's look at f equals to f2. So plugging this into here, we get 16 plus 16a plus, so this would be 4 times 2a, so 8a minus 8 plus, minus 8a plus 6 minus 2, and this is also not going to be equal to 0. Now the final one, f minus 2, we plug this in, and we can see here that this number here is going to be equal to 0. So this means that out of these 4 possible roots, the only 2 that actually worked were going to be x equals 1 and x equals -2. Now, because of this, we're going to be multiplying these two together, so x minus 1 times x plus 2 is equal to x squared plus x minus 2. Now we're going to use log division and divide this by this. So let's start by doing some long division. So I'll write this out. X to the power 4 plus 2a x to the power 3 plus 2a minus 2 x squared plus -4a plus 3 x minus 2. That goes into here a little bit, but it's okay. Divided by x squared plus x minus 2. First, going to plug in x squared, and we get x to the power 4 plus x to the power 3 minus 2x squared, and after that, we're going to subtract these two together to achieve 2a minus 1 to the power times x to the power 3 plus 2a x squared plus, we're going to drag this one down, -4a plus 3 x minus 2. Now we're going to divide this by, we say 2a minus 1 and times x. After that, we're going to plug this, we're going to multiply these two together and write it down here. So 2a minus 1 x to the power 3, 2a, so after that we minus these two together, we subtract them from each other, and this, so I can write minus 1 here, x squared plus x minus 2, and after that we just put a plus 1 here at the end, and we have 0. So this means that our new polynomial here is going to be a semi-factored one, which is x minus 1 times x plus 2 times the polynomial we got from here, x squared plus 2a minus 1x plus 1. Now, because we know that x equals to 1 and x equals negative 2 are obviously going to be rational in real roots, we just don't need to look at them anymore, and we can look at this part, which is a quadratic. So let's look at x squared plus 2a minus 1 x plus 1. And since we're just looking for whether or not the roots are actually real, we'll use the discriminant and the quadratic formula. Now we can see that the discriminant is going to be already using a triangle here, so you can see. So the discriminant is going to be equal to 2a minus 1 squared minus 4, which should be bigger than or equal to 0 for this root to be real. Now, you can see that there are two different paths here that we can take. First one being that I'll write like a little tree graph, so you can see the first condition is that 2a minus 1 is going to be bigger than or equal to 2. This means that a is going to be bigger than or equal to 3 over 2. Our second one is that 2a minus 1 is going to be smaller than or equal to negative 2. This means that a is going to be smaller than or equal to negative 1 over 2. And now we are going to draw a simple sort of line graph here. So I'll write it down here on the left. Now this is obviously not going to be to scale, but it's just here to show some things. So here are our two regions. Now the region that we have a to be possible in is going to be between this part and this part. So that means a has to be between these two parts on the left, and that anything that's and if a is equal to this part in between, it cannot be. It does not match our requirements. And what is this little region here? It is going to be a belongs to negative 1 over 2 to 3 over 2, and there are two integers in this region, 0 and 1. And because our original region, so negative 20 to 18, has 38 different integers, we know that our final answer should be 38 minus 2 divided by 38, which is going to be equal to 36 over 38. It's going to be equal to 18 over 19, and this means that our final answer should be 18 plus 19, or 37. So the answer to this problem should be 37. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye.